Yes. So before we actually graph them, let me show you what they look like. They have what we call an asymptote. Do we know what an asymptote is? Okay. Asymptote. An asymptote is an invisible barrier, okay? The line is not actually a part of the graph, but a line is there to keep the graph from going past that line. It'll never actually touch it. It'll get very, very, very close to it, but it'll never touch it. It's kind of like if you think about continually cutting a number in half. Will that number ever get to 0?
No.
No, you can always take half of a number, right? You start with 1, then you go to a half, then a fourth, an eighth, a 16th, a 32nd, and so on and so forth, but it'll never actually be 0, so it's getting closer and closer to that. So, these graphs have asymptotes.
Wait a second. Actually, if you keep breaking it down into the decimal form and it's 0.00002, and you take half of 0.00002, is 1, then it'll be 1, then it's never 0.
It'll never, because numbers are infinite, so it'll never actually be 0. It'll get very, 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 very close, but it'll never actually be 0. So this is just to use as an example, and I'll show you how they're different. This is the graph of a decay, okay? See how it starts out pretty high, and then it starts approaching this number, this asymptote here?
Oh, yeah.
Okay. So that's what a decay looks like. So let me show you what growth and decay look like. Again, we're going to have that A in front that can flip it up or down. So it'll be above the asymptote or below the asymptote. So, growth. Growth does exactly what you would think it does. It gets really big really fast. So it looks like, and this is my asymptote. It starts out hugging that asymptote, and then it starts going up quickly.
Why do they call it that?
Things like bacteria growing exponentially, okay, things like that. This is a lot of real life type things that we do.
What is growth decay?
I thought you just ate your breakfast, Ben.
It's a banana brownie.
Hold on. All right. Again, I'm going to have that A that's going to flip it, so it could look like this. It could also look like this. This is still a growth. That's just a growth with a negative A, and we'll talk about all those in a minute. I just want to kind of show you what they look like. Because I'm going to show you what decay looks like.
No, a decay?
No L, just AY. Right, David? So it's going to look like, it's going to start really big, and then it's going to come around and hug that asymptote. Not actually touching the asymptote like my picture does, but it won't. It hugs it, and then
away from the asymptote. It's growth, and if you get
correct. Yes. Good job. Yes. Boys. Ben, as in Ben. Hush. Yes, Tyshawn.
It is where 0 is, right?
What? The asymptote?
Like you said that it can't go, it represents how the graph doesn't ever reach 0, right?
It could be 0. In the example that I gave you in the beginning, it was 0. But that asymptote can shift on the coordinate plane anywhere.
So it's if the arrow's going left versus going
So
right.
it could be any point that it just never really ever touches. It just depends on where the asymptote is.
Correct. Yes.
So growth versus decay is like if the arrow's going left versus going right? Because
Well, it has to do with, if you look at,
what side of the graph
guys.
it starts on?
It has to do, so this one's just flipped over here, okay?
Well, yeah,
So if you look left to right, it's getting really big, really fast.
Yeah,
so
so I'm
it's
saying
growing.
it's going left
It's going
to right
away
versus
from the
right to
asymptote.
left.
Right,
Yeah.
right. All right, let me show you the equation, because the equation is what we're going to use to graph it, okay? Ready? The equation is the same for growth and decay, but I'm going to show you how to recognize whether it's growth or decay. I have that same A in front. Yes, Ben. You haven't written anything down, Ben. You need to be able to look at it and tell, too. All right. A times B. Yes?
Is that H?
H. That's an H. These same variables just keep on showing up. All right. Couple things you need to know this time. Shh. Guys, I need you with me. This is important. A, okay? This tells me if it's above the asymptote or below the asymptote. Okay, so if it's positive, what do you think it goes? We're above the asymptote. Okay, if it's negative, then it's below the asymptote.
Miss B, give me some luck for my birthday.
Well, stay focused, Matthew. The A has no impact on whether it's growth or decay. It simply tells you if it's above the asymptote or below the asymptote, okay? It also has to do with the shrinks and stretches, but we won't worry about that quite so much with growth and decay, just the above or below. The B is what tells us if it's growth or decay, all right? B is never going to be negative, because if it's negative, that means the A is negative. B, bigger than 1, tells us that it's growth. And less than 1, now remember, if it can't be negative and I'm talking less than 1, then I'm talking what?
What?
A fraction, yes, a fraction less than 1. Then that tells me that it's decay.
What are those signs?
Greater than or less than.
No, but there's a line next to it.
Greater than.
Oh.
The K is my asymptote. And remember, these are horizontal asymptotes. So this is Y equals K is the equation for my asymptote. If it's not there, what value does K take on?
0.
0.
So if it goes like if you like messed up on the fraction or like messed up setting it up, and it goes like through the
Asymptote?
asymptote.
You've done it wrong. You know you've done it wrong.
It's like a seatbelt.
Well, so I don't get the whole the K thing. So
These equations apart and look at them before we actually graph them. Couple things I want you to tell me about it.
Oh my gosh, why are we doing so many?
Why did I do the same one? Look at the first one.
You are missing the A.
Well, but that's not what I want you to tell me right now. Right now I want you to tell me, first thing I want you to tell me is it above the asymptote or below the asymptote? Why?
It's negative.
Negative.
Below the asymptote. Is it growth or decay and why?
Okay.
Why?
It's less than 1.
1/2 is less than 1, right? That tells me it's decay. What is my asymptote?
-3.
So it's if I was on a graph, I would be down 3, and that's where my asymptote would be. Okay? And I know that it's going to be somewhere down here, and it's decay, so I could go from there. Let me also tell you this, and if you would go back for just a second. One point that's always on the graph, no matter what, I'm not going to call it a starting point or anything like that because it's really not. It's just a point on the graph, an easy point. Is always H, A plus K. Okay, this one's a little different because I have to add the A. But the H is still opposite sign and then A plus K. That's going to be a point on your graph. So that's one you have to do absolutely no calculation to find. It's there for you. Okay, we can take it away from the equation in the beginning.
And that's like your start. Is that your start point?
It's just an easy point on your graph. So if you look at this first one, what's an easy point on that graph?
2,
Change the sign on H.
Which is
-2, -3.5.
-2. You sure?
2.5. -2.5.
What is?
-3. Bruh, it's negative.
Tell me this.
Plug it in the calculator.
Tell me this. What is B?
B equals
-1/2.
-1.5.
That's
B?
positive.
Positive 1/2. B can't be negative. So what is A?
-1.
-1.
Well, I don't know.
So what is?
It's 1/2 or negative 1/2.
I know.
It's 1/2. You have-
Remember H, A plus K.
Negative
If
2
A
and a
is
half.
negative 1 and K is negative
Is it
3,
negative 2 and a half?
negative 4. This is the same thing as negative 1 times 1/2.
How is that an easy point?
Because that's way easier than trying to plug in this whole equation and find what it
Wait,
equals.
so the A is -1?
Yes.
Debatable.
If there's a negative in front, that makes A negative 1.
Times that is the same as output.
Correct. B cannot be negative. Look at the second one. Is it above the asymptote or below the asymptote? Above. Why?
Because it's a positive.
It's a positive A. All right. Is it growth or decay? Why?
Because there's
2/3 is less than 1. What is the equation of the asymptote?
0.
Y equals 0. What is an easy point on the graph?
Negative 5? No.
Or 1/5.
1, 5. H,
Yeah.
K is 0 because it's not there, and A is 5.
So, do we imagine the x minus 1 is in parentheses?
Yeah, you can, yeah. Yeah, because it goes with the exponent. It's on the exponent. How about the last one?
It's
Above or below?
below.
Below.
But it's growth.
It is growth. Even though the A is negative, that has to do with above, below. It doesn't have to do with growth decay. Because 4 is bigger than 1, that tells me it's growth. How about asymptote?
Negative 1.
Negative 1. How about an easy point?
Or 0.
0, because H is not there, so it's 0. And so then I do negative 1 and negative 1/3, which is negative 1 1/3 or negative 4/3. Does that make sense before we graph? If you can do this, graphing is a piece of cake.
Can we use our calculator to graph?
You can, but you must show me all this work.
Oh,
So, in other words, you can use your calculator to check it, but I want to
You
see.
need an easy point. You need to show an easy point, and you can graph.
You gotta know how to
You gotta have 2 points. An easy point, then we're gonna talk about another point. Y equals, we'll start easy. 3 to the x plus 1 plus 2. Before I graph this, is it going to be above the asymptote or below the asymptote? Above. Is it growth or decay? Growth. Why?
Because it's above y.
3 is bigger than 1. Good job. All right. So here's what I want to do whenever I graph them. I want to start. I'm going to do right down here. I'm going to say to graph. I want to graph my asymptote first. Asymptote. And you told me, or you haven't told me yet, but what is the asymptote?
2.
2. So y equals 2 is my asymptote, so I'm just going to come to 2. Does that confuse anybody? Easy peasy. All right. Next, I want to plot my easy point. And remember, we said easy point was
Is it negative 1,
Opposite
4?
edge.
A plus K, right?
Yes, negative 1, 4.
Negative 1, 4. Negative 1. No, not 4.
Wait, but 3 plus 1. 3 plus 8.
H. A is what? What is A?
A is 1.
1 because it's not there.
I thought it was 0.
K is...
If you're adding or
Oh,
subtracting.
K is 2.
All right, negative 1, 3. Did we all see where that came from?
Yes.
Okay. So now I need one more point. This is the only part where you're actually going to have to do a little bit of work. Okay? You hate work. Okay. We need another easy point. I'm going to call it easy point 2. Pick. It's going to be the same process we've used for every other one we've done.
Pick a number and
Pick a number right beside the h that you started with, so add 1 to it. So here I'm going to take whatever h was, add 1, and plug it in.
To H or X?
For x. So here I'm going to use, since I had -1 exactly, I'm going to use 0. Okay? When I plug that in, I get y equals 3. Well, 0 plus 1 is 1.
So 3 plus 5? 0.
So it's 5. So 0, 5 is my easy point number 2.
Okay, that just doesn't seem like it's a whole number.
Well, this really just tells me
is it
which
gonna be
direction
like
to take the graph. That tells me it's got to hug it in this direction, and it's going to increase this way. That's all you need. 2 points is good for me. I'm not going to make you do a whole T-chart of points. I know you can use your calculator at this point, too. I just want to make sure you understand how, if we needed more points, we could definitely plug more x's in and go from there. The thing is, the further you go for this graph to the right, those numbers are going to get huge fast, right? So you really want to stay close. Yeah.
If you ever did need to find more points, you just keep adding 1.
Yeah, that's good. How about the domain here?
It would be
Negative infinity, positive infinity, because that's left to right. All of these are going to have domains negative infinity to infinity. We won't switch the asymptote to a vertical one until we get to logs. What about the range, though?
2 to infinity?
It would. This time, I'm not going to do a bracket. Why?
It never touches it.
It never touches it. Good job, Drew. You can't, it's an asymptote, it's a boundary, it's a barrier, so it doesn't touch it. It gets really close, but it doesn't touch it. So it's a parenthesis. So from 2 up. Does that make sense?
If it's a negative, do you put the negative infinity on the other side of it?
Yes,
Like
if
an
it was
X.
below the asymptote, yeah.
I always get
That's it. That's -2 times 1/4 to the x. So my first step is to find the what? Asymptote. Well, tell me this. Is it, go ahead and do that. Is it above the asymptote, below the asymptote? Below because it's negative. Is it going to be growth or decay? Decay because it's less than 1. Where is the asymptote? Zero. K is the asymptote, the number on the end. If there's not a number on the end, then it's 0. All right, so my asymptote.
Well, I mean, like, which number does it mean if it's below it or above it, like that?
The number in front. If the very front number is positive, then it's above. If the very front number is negative, it's below. That's your
The
A.
very front number is not negative.
B cannot be negative. A can be negative.
Oh.
All right, easy point. What is it? H, which is 0. A is 0, -2. So here you see I'm below the asymptote, right? I need another point to plug in. What should I use? 1?
1.
Y'all are very hesitant with that. 1, yes. Move over 1 from your easy point. Now plug it in. -2 times 1/4 to the first power. What does that give you? -1/2. 1/4 to the first power is 1/4, and 1/4 times -2 is -1/2. Yes, right, David? That phone tell you that answer? Mm-hmm. All right, connect them. Hug the asymptote. Domain.
Negative, positive.
Good job, Ben. How about the range?
Negative, like,
Negative brackets. I mean, not brackets. Parentheses.
0, yeah.
What?
Yes or no?
Yes, but give me a second.
Do we need to do another one, or are you? Yeah, one more. Okay. This one's going to be one do on your own, and then we'll come together and do it together, as per your request. Here we go. I'll make this one a little tougher.
In the domain, it never really touches anything, so it's
All right, I'm gonna pause the video and let y'all copy it, work it, and then we'll do my line here down some. All right, guys, let me reel you back in. Is it gonna be growth or decay?
Decay.
Why? The 1/2. Okay. What is the asymptote? Oh,
-2.
-2. What am I doing? I'm thinking so. Okay. -2. Give me the coordinates for an easy point on this graph.
-5, 4.
Because it's H and then A plus K. So 1, 2, 3, 4, 5. 1, 2, 3, 4. What'd you plug in for your second easy point?
-4.
-4. When you plugged in -4. 1/2 -4 plus 5 minus 2. 1/2 to the first power is 1/2. What's half of 6? 3 minus 2 is. So what are the coordinates of that point?
-5, 1.
Did everyone get that?
Wait a second.
Wait a-
How do you get 4?
I thought you helped Josh with this one.
Oh.
Yeah, I seem to have gotten the.
Okay.
Why
How
did
did,
I plugged in.
How do you get 4 in front of the 1?
I plugged in a +4.
No, because you choose.
I got like-
so
That's what she plugged in.
But my.
you got probably very, very, very close to that asymptote. Yes. Yes, that's fine. Ben, what did you say now? Okay. It shouldn't cross over that asymptote. My pen slipped a little bit. How about domain quickly? And then I'll let you do your homework.
-1, positive infinity.
-2.
Negative infinity, positive infinity.
How about range?
-2, positive infinity.
Good job.